So I'm Andreas, as the name would suggest, and I'm working for Epson since January 2003, so for a bit more than 20 years. And I'm responsible for, well, I will tell you now. You've heard a lot about, that's why I don't need to talk about it, about the why. The why means, why should you take action, whatever is regarding sustainability. By the way, if you do not know the guy, Simon, here, check it out. There's a really famous talk, TED Talk, about why the why is important and why you should start with why. That's really, it's a great part. But anyway, that's all covered by Stefan, by Henning, etc. So why you should act and why it's maybe even a bit late. So what we're doing. And you will that's why I'm only using a few pictures and images, but I will not continue with this. You heard enough of it. Just a few slides on the why. And so why should everyone act? And even if it's quite late, because you can't make business if there is no one to have business with. So if all islands of Germany and if the north of Germany is dying, with whom do you want to make business in Germany? And the same goes for the other islands. So that's pretty tough. So I will skip a bit of the part. What's interesting, why I'm here, is because everything regarding sustainability is part of our means Epson, own DNA. So what we are doing is part of our culture. And that's interesting. That's maybe one part I would suggest that everyone should check out what is your DNA, not from a biological point of view, but what is your aim and why you're doing business, and are you really sustainable in whatever way? My talk is about closing the resource loop in the industry, and I'm doing this because we are here at the drupa fair. So that's why it is important. And this is not about the why, but this is about the how. So the why, you have heard now a lot from Stefan, from Henning, but you still do not know maybe why, how you should do it. And there are several ways to do action on it, especially in the printing industry. And the simplest way to change everything, but that's in a way old technology, is change from heat technology. Heat technology means everything which contains toner works with heat, with a lot of heat, and produces a lot of CO2 and a large carbon footprint. But you can switch easy. That's the easiest way. I only have this one slide for it. So, but that's the easiest way to take action, switch to cold, to heat-free technology, and then you're doing a big step forward for the environment, for nature. So that's a very easy part. But you most probably know about this because that's Epson. So that was no, I'm just kidding. My part is a more tricky part, and that's a new segment where we are stepping in right now, we as Epson. And this new segment is recycling. So you know Epson because we're making whatever, projectors, scanners, printers, but now we're stepping into recycling. And that's quite interesting. Recycling means today this machine, and in the future a few more machines. Is my sound connected, by the way? I will see. So these are the technologies we're using today. So we're using today printers and projectors and robots and whatever. But we're now having a new segment, and this new segment is called dry fiber technology. Or in German language, Trockenfasertechnologie. It's all a bit weird saying it in German or in English. But anyway, so dry fiber. What are we doing with this whatever stuff dry fiber technology. Basically, it's quite simple. We do have a machine, today quite big. You're feeding in from the one side raw material, let's say paper or wool or whatever, and you're getting stuff out on the other side. Basically, that's it. But it's not like a very big plant from the size of a hall, but it's something that is less big than the stage here at the booth. So it's very simple. And in this case, we were starting with this product, quite simple, the product. So you're feeding paper in. There's a big paper tray here. You're pressing a start button. And 3 minutes later, you have recycled paper. Well, that's done. Well, yeah, it sounds a bit weird, and you should see it because it's really amazing. You're just feeding in printed paper, whatever, printed with toner, with ink, feeding it in, start button, 3 minutes later, recycled paper. And the best part, without water. So we do not need any water to get the ink or the toner out of the paper. It's purely mechanical force. And now you're getting the point where Stephen and where Henning were pointing to about the lot of water that is needed. This is a recycling process that is working water-free. We're still using a bit of water for the humidity inside the device, but that's in a way peanuts. Compared to traditional recycling, we're using 98% less than everyone else. So that's how it is working. In a bit more detail, what we're doing, and that goes really quite quick. So this is a 3-minute process. In the first minute, we are shredding and defibrating everything. And this goes, actually it's not a minute, it's a bit less, like 30 to 40 seconds, then it's done. So within 30 seconds, every sheet you're feeding in is destroyed to fibers. It's completely destroyed means, is anyone here knows about shredders and devices for security? No? Well, if there would be someone, you would now probably say, oh yes, I know, there are P4 shredders, P5, P6. I'm not quite sure about P6. This device is a P7 shredder. P7 means that's the highest security level you can have. So all current customers buying this product, they're doing it because it's the best, the fastest way to recycle paper. It works without water, and it works from a security level to the highest point you can ever reach. So that is done like in the first minute. In the second minute, that was shown already partly by Henning, we are controlling the fibers. So first we defibrate. Now we have single fibers. Now we're putting those fibers back again, putting a kind of glue, a binder to it. And in the third minute, it gets pressed quite heavily. We are cutting it into A3 or in A4, put color to it or not, whatever the customer wants, and then we're done. That's the easiest thing to do. And that's not future technology. It's in the way like the printers from Epson. It's basic technology that you can buy today. So that is about the how. How can we make a difference? How can we act or produce differently? And we are not only producing paper, so what most customers are doing, they're creating their own notebooks, their own calendars, their own business cards. Even my business card I produced by my own. So because it's quite simple, I simply created A4 sheets, cutted them. Okay, I use a different machine for the cutting, etc. But then it's done. So that's the easiest thing to do. And that's about the security level. Can someone give me bit of the timing? I'm still in my time? Yeah, perfect. Okay, so security is the biggest level. So we are not only targeting the topic of sustainability, but we're targeting the topic of security. And that's why the current customers are most of the time big banks, ministries, insurance companies, big industry who have a high demand on deleting all personal information. And that's what we are able to do. But this is only the beginning. Henning, you were talking about 2050 and 2030 and what is happening until that. And I was saying that we, as Epson, are stepping now into a new segment. So this is already available. That's basic stuff. I shouldn't have the need to tell you about it, but no one knows. You didn't know before, right? Yeah, no one knows. Probably my fault, but now you know. But we're doing more. We're doing more in terms of recycle. In the future, we will recycle everything. And with everything, I mean really everything. First, we're starting with fiber. So with fiber means we're not only recycle paper, but we will recycle clothes, because they also consist of fibers. That's the easiest way. And then we will continue with plastic, with metal, card boxes, whatever it is. We will recycle everything. And we will not do it in a big plant, but we will do it locally. And doing it locally will have a big impact, because it's not only impacting your company on your own, but we will have an impact on all those countries in South America, in Africa, etc. They have suddenly their own resources back again from what we're doing. So whatever there is as raw material, we will use it and we will work with it. And this is what we're doing. One short comment. Well, actually, this is not natural material. This is artificial. Artificial means if we are creating whatever, like a new code, like this one, and I would now bring coffee on it. Do we have coffee here? No. And I'm not allowed to do it here because of the, yeah, but I could do it, and it will have no effect on it. No effect means we can create fibers that are whatever, water resistant or UV resistant, or we can create plastic stuff that is antibacterial. We can do everything by not only doing the recycling, but adding artificial fibers on top of it. It's in a way like you have today paper, and you ask, how do you create coated paper? We will do on our own in the future by adding a short layer on it with those machines. Nope.
Become planet-friendly material that helped us manufacture a more sustainable future. And finally, close the reduce, recycle, reuse loop to create a circular economy. It's that ambition that led Epson to establish a new vision for low-impact manufacturing and introduce our world-changing dry fiber technology. It all began when we started thinking about what happens to printer paper after it's used, and whether we could return that paper to a raw material for reuse. Dry fiber technology gave us the answer. Using mechanical force instead of water to separate paper into tiny fibers opens the door to huge possibilities. This new fibration process is quick and means the length and shape of the fibers can be controlled accurately, allowing them to be reused far more easily than with a water-based fibration process. And because it's far easier to control the density of fibers, you can also give materials different properties, such as harder surface, greater strength, or more flexibility. And if this is possible with paper, there is a far wider range of materials that could potentially be upcycled by defibration, such as silk, wool, wood, cotton, and even artificial fibers. It also means that it could become possible to integrate additional materials into the fibers to create new raw materials that have many different functions, including flame protection, water repellents, antibacterial agents, fertilizers, binders, and conductive materials. The first application of our dry fiber technology came in the form of absorbent printer ink pads, made by loading used paper into machines equipped with dry fiber technology. This was followed by the world's first dry process office paper making system, Epson's Paper Lab. But there are more possibilities on the horizon. By separating used paper into fine fibers, you can produce the sugar needed to cultivate Euglena, a single-cell organism that can be used to develop naturally derived biomass plastic. We are only at the very beginning of this development, but it could be a vital step in driving down the use of more harmful petroleum-derived plastics and making possible a world powered by the low-impact manufacturing of anything, from furniture, household items, and even home insulation, through to packaging, construction, and heating fuel. So what began with a desire to reduce waste paper could eventually revolutionize manufacturing around the world, leading to a more natural, more sustainable, more positive future for everyone.
Okay, a lot of buzzwords inside, I admit, but if you read carefully our current sustainability report, you might come to a phrase where it says, oh, Epson will become underground resource free by 2050. Underground resource free means we're not using any whatever oil, metal from the earth. What does that mean? Aren't we producing printers? Don't we need chips, semiconductors, plastic in any kind? We will need, but we will use existing material. We will recycle everything. And that's how we can become carbon negative and underground resource free. We'll have a discussion before how far we are, and before 2050. So thanks a lot.